Please welcome back Hurricane Bob.
Whoa, you blow me away. So that's a direct quote from the Climate Champions Awards. And everyone was wondering, and by the way, I do want to thank so much my board of directors. I mean, we've never changed our board. And as far as I am concerned, thank you, Ian. As far as I am concerned, we're not going to change it. We have an amazing board. We've been together since day one, and we're not going to change it until we're done. And that's the way it's going to be, I hope. And so I have to say, Tom, thank you, Tom Lewis, and Dan Digraph, and Alex Gerhardt, who's in Portugal, trying to get married. You know, I mean, I should tell some jokes about that. I tried twice, and here I am. Anyway, but, and Elizabeth Moore, who really, you know, she's the heart and soul of our environmental movement. And I have to say that what fun we have had doing all of this. It's been such a joy to work with everyone, and I feel like every single one of the people involved in this have become like major players in my life. So I'm just so grateful, really, to have the opportunity to do something like this. And it's kind of the culmination of what I really have felt my whole life. Of course, I'm a geek. I'm a scientist, and that goes without saying, and I'm kind of proud to be a geek. But on the other hand, I realize that if we don't connect science with society, then what the heck? It's nice to know, but we're not getting the impact we should. And right now, we need that impact. So for all of you who are here and the many who support the CAC, I really appreciate all of you. And I do want to say we just had the Giving Challenge, and I don't know if you know how that works, but we get matching grants and all of that. And the Giving Challenge this year, which was amazing from my point of view, and I think Rick Kirby, he and I really were the keys behind that. But in the donations category for a small 501c3, out of 255, we came in number 6. I was the most surprised person. So anyway, we have a great community, and they're getting it because they don't give unless they really get it. But so anyway, I want to move on to the forecast here so I don't start crying, and I don't want you to cry. But I really want to tell you that, you know, we're very proud that we make this hurricane forecast. It's the only one in the whole United States that's really forecasts the Atlantic Basin hurricanes, but with a special emphasis on a place, and it's on this special place. And this is our track record for the last 3 years of what we forecast and what we had. And I'll tell you that it's the most accurate forecast in the world on major hurricanes as of right now for the past 3 years. There's not NOAA, not AccuWeather, not CSU, not anyone else has a track record this good. And the reason is because we've been watching, well, in my case, I've kind of grown up with hurricanes. Like, I flew into them and thought it was fun, you know, so that'll tell you something. But anyway, the reason we do it now is because the threat is measurable, and we can use that threat to launch us into a resilient future, and that's what I really care about. And this is the different hurricanes that we've had last year and how they went through rapid intensification. And it's amazing that last year we had Hurricane Erin, which is a Category 5, that increased 85 miles an hour in just one day, the wind. Those winds that you see, like 160 and 130 and 130, that was the difference between when they started a rapid intensification cycle and when they ended the rapid intensification cycle. It is not the story about what their maximum wind was. Stu mentioned Hurricane Melissa. By the way, my oldest daughter is named Melissa, so she was really excited when it formed. And then she thought, oh my God, it's the worst hurricane in history. What the heck? How did that happen? But anyway, a drop zone that was dropped by a NOAA hurricane hunter as the hurricane was coming ashore measured a wind just above the surface of the ground of 255 miles an hour in gust. It was verified afterward, and today is the highest recorded wind speed ever measured in the world. And it was last hurricane season. Those storms, even though we didn't have that many last year, went through 23 cycles of rapid intensification, the ones that we did have. This never happened before, and this is a direct link with the warming climate and warming seas. So the message on this is, it's not the number of storms that really matters so much, but these things are the things that are really important, because this is what changes people's lives. And the fact that it's happening more and more just means we need to be better and better prepared. Our definition of being prepared in 1990 is way different than it is in 2025. I'm not really sure that everybody understands that, but that's what we're trying to help them understand. And so these are the factors that I look at for how we make our forecast. And obviously, sea surface temperatures are on top. And Stu talked about ocean heat, how ocean heat, the depth of the warm water makes a big difference. And the world goes through various oscillations, and there's one in the Atlantic that's called the AMO. And it's a 90-year cycle, and we're about 30 years through a warming phase. So we've got another 15 years roughly to go before that cycle actually starts working in our favor. And then, of course, you've heard about the Bermuda High, which is the big high-pressure system that steers the hurricanes, sometimes out into the ocean, but sometimes into the Gulf. And so that's why we like to look at that. And then there's all these other factors that we look at that helps us make the forecast. So, you know, there's a lot to keep track of here, and not all of them support one thing or another. Sometimes they're contradictory, and that's what we have this year. So I want to give you to start with sea surface temperatures, two examples. The image on the left is last year's ocean temperatures taken from the same satellite, and the one on the right is this year's. And what you see is, oh my God, the whole Atlantic Ocean is like pretty warm, except over by Africa, which was really cool last year, which was part of the reason we didn't have a lot of Atlantic hurricanes come across the Atlantic. They kind of formed over by, you know, Cuba and the Puerto Rico and Jamaica. And if you look there, you can see, actually I have a very nice, you see this right here, this is the loop current. And this is the hot pool of water that if something should go over that, it's going to rapidly intensify. If nothing goes over it, we don't have to worry. But if something does, that warm water is sitting there. It's already there. And this is ocean heat, the depth of the ocean heat, the 2 years side by side. And they look very similar, but what I want to point out is what I pointed out last year. You see, here's that ocean heat, and that's where Hurricane Melissa ended up a couple months later and rapidly intensified. So it's like, it's waiting to happen. The right ingredients have to come together. And if you look at this year, it's not that much different. And here's our loop current. Look at it. It's just sitting out there in the Gulf. So we're watching that, and if something goes over it, then, you know, it's a good indicator that something is going to blow up as it goes over it. And this is a side-by-side of the Gulf of Mexico temperatures. And you see last year, there was a cool pool of water right near the west coast of Florida. And you can see the loop current in the red next to it. But now look at this year on the right, and you'll see there, that cool pool of water isn't really there. But look south of Cuba. It's cool there this year, but the Gulf is warm. And look at the Atlantic. Look at this. Like, this is way far north. The Carolinas, the east coast of Florida, the northern Gulf. So, you know, it's lopsided. It's in a different position than kind of what we've seen in recent years. And I love this. This is a cool image because these are all the ocean currents on top of the temperatures. And you can see the cool temperatures here, and here's Florida, and here's the loop current. And here's how the water flows around and up. So it's amazing what we see on satellites these days, right? This is amazing that we have this kind of data set now. And we have this globally. When I started in my profession, there wasn't satellites. So I'm not telling you how old I am. Okay. So here's a different look. This is a chart that shows all the years of the Gulf of Mexico, or the Gulf of America, whatever you want to call it, the temperature. And that little block on the top left-hand corner, I guess it is, shows the area. And if you look at this blue line, you can see how it's tracking, and you can see these are the big years. And it's tracking kind of parallel to the worst years. So you don't hear a lot of people talking about this, but this is something that's there right now. But if you look at the Caribbean, you'll see it's warm, but it's not quite as warm as it was in other years. And then if you look at the entire, what we call the main development area, the temperature is, no, is this the, oh, this is the El Nino area off of the Pacific. And look at that temperature. That's the warmest temperature ever recorded in the Pacific. It's right now. So a El Nino is forming right now. That little block there at the top shows you the El Nino area out in the Pacific. So we have an El Nino, which is usually supportive of a low hurricane season in the Gulf, forming right now, and we have very warm sea surface temperatures happening at the same time in the Gulf. So look at that. And I'm sorry, this is the El Nino area, and this last one was the mid-Atlantic, where off the coast there you can see, I'm kind of worried about this area for later in the year. But then here's the El Nino area, and you can see like record high, by a lot, sea surface temperatures. Okay, so the Atlantic Oscillation, which basically has two phases, a warm phase and a cool phase, we're in a warm phase, and it looks like we're going to be in a warm phase for quite a while. So that's supportive of more hurricanes. And then we have what I call the Bermuda-Azores High, and this year it's kind of like a big bubble. And we have two different locations. One is kind of over Bermuda, and one is kind of over the Azores, and it's kind of one big blob. And when we have that kind of thing, it shunts anything that forms sort of toward the United States, whereas last year, we just had this one. So it went up like this. But this year, we have more of a blob. So that's supportive of whatever does form moving closer to the United States and maybe into the Gulf. Now, you hear about the El Nino forming. Well, this is the very recent, like I believe 2 days ago. This is the compilation of the sea surface temperature. And you can see it was cooler, it's been warming, and this is where it is right now. It's almost at zero, which demarcates it's a neutral condition right now. But these are all the models, and you can see every single one of them is predicting that the warming is going to continue. That means likely we're going to have an El Nino and maybe a super El Nino by late in hurricane season, and that's the S. When it gets above that line, it's defined as a super El Nino. So you could, on the one hand, we have a lot of favorable factors, and on the other hand, we have some that could be pretty unfavorable. In fact, this is the prediction for El Nino versus nothing. There is no probability for anything else in the models. It's all forecasting El Nino. This is neutral. This is September, October, November, 3-month periods. This little gray box is neutral conditions. You see, that's what it is right now. And the El Nino keeps getting stronger and stronger as the year goes on. So what that tells me is the early season is going to be the most conducive time, probably, for storms. And look at this. When we have a La Nina, we have more hurricanes. When we have an El Nino, we really have a lot less. But the key thing is it's not zero. And in the age of rapidly developing storms because of the warm water, we can have major hurricanes even if there aren't many. For example, 1992 was an El Nino year. We had no hurricanes till August 16th. And then on August 16th, out in the Atlantic, a little blob formed that became Hurricane Andrew. The first storm of the year, a Category 5, hitting a major metropolitan area. That changed life in Florida. That's why we have the buildings we have today. So, I mean, we learned something from the experience. So, another thing I look at is wind shear, and I've showed you this before, but when there's no wind shear, it means the winds at the lower level and the higher level are basically the same. And when a storm does form, it can stack up vertically very nicely. And it's just like the skater, that goes into a spin. If they're on their axis and they bring their arms in, they spin faster and faster because it's the conservation of angular momentum. When we have shear, it blows the tops off, and the energy doesn't get conserved in the same way. We can still have storms, but they're not as severe. So we kind of like wind shear because it decreases the number of really, really strong hurricanes. And El Nino is our friend when it comes to that, most of the time. So what the hell does Africa have to do with all of this? Okay, so this is the area in Africa. It's called the Sahel, and you've heard me talk about, and Stu, about African dust. And this is where the dust comes from. But if that ground is wet, the dust doesn't get into the air as efficiently as it does when it's dry. So this is the forecast from our best model in the United States of what it's going to look like. What month is that? In August. And you will see the green blobs are wet and the brown blobs are dry. But most of northern Africa is white or green, meaning they're going to have normal or above normal rainfall. That means less dust over time. We're kind of having a lot of dust right now, but that dust may not be what it was last year when we had dust all the way through the major part of the hurricane season. But when the dust settled, we had 3 major hurricanes, 3 Category 5 hurricanes. And there's, his picture was better, but I like this one too. But you know what's cool on this one? Look at this. Here's the dust, and here's an easterly wave coming off of Africa outside the dust, and it knows where to go. That's the environment that we can have dust and we can still have hurricanes scooting around the bottom of it. And so here's our best climate model in the United States for June. And the green areas are above normal precipitation, which suggests storm paths. And you can see, coming off of Africa is pretty darn dry, but in June, we have a little slot there coming up from the Caribbean toward the west coast of Florida that is showing wet. And this is just a couple days ago. And so these are sort of like favored areas for June where if something were to develop, what the path could be. In June, we're still going to be in neutral conditions as far as El Nino. We're going to have mid-level moisture, and we have a warm Gulf of Mexico. So June may be a month where we have a named storm in the Gulf. And so that's kind of how the odds are that this is a month we'll have to watch right here. And then I'm going to show you, let's see, what month is this? It's July. And you can see how it's dried out over Florida, but kind of down in the southwest Gulf of Mexico looks like it could be active. And you can see a little slot like south in the Caribbean that might open up for a storm. So perhaps the south Texas coast and the coast of Mexico would be a favored area, but and then maybe the remnants coming up through the northeast. And then another one off the coast. This is interesting. Right where that warm water is in the North Atlantic, that could be an active hurricane area, but it looks like most of that would be off the coast. And then September, look at the United States. You know what that is? That's El Nino. That's El Nino coming in a big way. And you can see there is kind of a little a little transition in the Gulf of Mexico here during peak hurricane month. And it's kind of over where our loop current is warm. It's not in the Southern Caribbean. It's not in the tropical Atlantic. It's far north. And I am a bit worried about late August and early September as being sort of an opportunity for a hurricane in the Gulf. And, you know, these are the kinds that can spin up very quickly. And it sort of reminds me a little bit of what Milton really looked like, because we had a lot of shear north of the hurricane. The hurricane went just south of it and just made a beeline to the coast. How this sets up is going to be really important, but this is what it looks like today. It will change over time, but I'm trying to give us a little bit of fidelity on where potential threats are for us. And then, holy mackerel, this is peak hurricane season here, but all that rain in the Gulf and everything, that's El Nino. That's not a hurricane. So that means if we don't get hurricanes until then, we're going to get rain here in Florida, and we're finally going to ease this drought, which is epic at this point. So better days are ahead in November from the point of view of getting some moisture in here. And if there are major hurricanes out there, they're going to be recurving up as that wind shear comes blowing through this area here. So again, I want to drive home how different the world is today versus how it used to be. But this is what the last 10 years looks like. 17 storms a year. 8 a year for the last 10 years, and almost 4 a year in major hurricanes. This is only a 10-year record, so it's not long enough to be statistically accurate, but I think it's something we should watch, because this is what we've been experiencing. It's no wonder we've had billions of damage. So these are all the factors, and I rate them here. I'll let you read them. There's a lot of different ones. But, you know, under probability, these are the probabilities. I feel confident that what I'm telling you today is highly probable, and where I say it's low, it's because I don't feel confident enough to make a big judgment. And here are the others. And it's kind of I don't know, it's kind of an enigma, like it always is, and we have to still figure out what the most probable thing is. And that's what we do. We're not saying what it's going to be. We're saying what's most probable, okay? It's not yes or no. We're using probability to help inform our decision-making. And so here we go. Here's the forecast. Are you ready? Below normal. Like last year, 5, that's below normal, but what we're used to. And then major hurricanes. So, but I am saying this with the caveat that 2 major hurricanes is still, depends where they are. And so that doesn't mean we can go to sleep this year. We still have to be vigilant. And if things change, I will let you know. But here are the names of the hurricanes for this year. Does anybody see their name in there? Who's here that has that's great. That's the first time that's happened. Oh! Okay. We better not get the... And then I want to point out to you how different life is on the Gulf Coast. This was an El Nino year. We had a hurricane that came right up kind of where I see the possibility of one possibly coming in June. And it was far away from Sarasota, and we had 3.5 to 5.5 storm surge with a storm that you can see it was just becoming a major hurricane as it was going by. It was far away, and we had dramatic, important impacts from it. This did not happen in the 20th century. It is unique to this one. And then look how far Hurricane Helene was off the coast. It was nowhere near a direct hit. And 6.7 feet of storm surge on the bay in Sarasota. So we don't need a direct hit by a hurricane to have major impacts here. That is the takeaway. We can have storms go by, and we're still going to have major impacts because sea level has risen so much. So, just to sort of like regurgitate this, I guess. So the living laboratory is the logical response. 7 inches of sea level rise here in Sarasota since 2000. Major impacts that we have from hurricanes, whether they're direct hits or not. You know, we have the equipment, we have the sensor systems, they're all out there that we can install. And this is really an important, I think, feature of what we can do to be better prepared and to measure so that we can invent these new products for sustainability, because you cannot predict without measurements, and we don't have them. Do you realize that during Hurricane Milton, to use Dr. Franco's example, the anemometer blew away at 105 miles an hour, so a Category 3 hurricane was never recorded in Sarasota. It's not because it didn't happen, it's because the instrument blew away, and we only have one, and we're going to fix that. The test bed is so important that we have the data to inform new product development so we can test it and then roll it out in society so science actually serves society and not just science. And because an ounce of prevention is worth a pound of cure, that's what my mother told me. But it's actually almost 2 ounces of prevention, because it's a 30-to-1 return on investment at a minimum when you have something like what we're proposing, and it can be multiplied in other places, not just here on the bay. So who wouldn't want a 30-to-1 return? Is there anybody who would not accept a 30-to-1 return? Well, we need to do that. We need to accept that. And I want to say that a lot of people don't like making choices, so they don't. But in this case, not making the choice is the worst possible choice. So we need a model that lowers the risk and not the tax base, okay? The living laboratory protects and grows that tax base in a time when we want that to happen. And so it's our innovation corridor. It will attract new innovators to move to Sarasota to help solve a global problem, using Sarasota as an example, it will help this university community in Sarasota attract the kind of students we want. It will empower our own sense of safety to our own personal investments, our regional investments, our community investments. It lifts the whole community. Where we innovate, we make progress. So I don't know, will Sarasota play to win? It ensures that, Sarasota continues to be a special place and doesn't devolve like many communities will, because they will not make the choice, into just another place. So I like winning. How about you? Thank you very much. Thank you. Thank you. Thank you so much. How about some questions? Greg.
Yeah, first I want to say I want to be a member of CAC.
All right. See, Tom. Do I hear a second?
So you talked about blended, is this on? Yep. Okay. Talked about blended water temperatures. Is that a variation of, like, from various depths, you're blending temperatures? You're talking
Yeah,
about,
so in other words, there's a lot of ways to measure temperatures, and it's not just the atmosphere we want to measure. We want to measure water temperatures in Sarasota Bay. Like I said, the bay isn't just in the water.
Right.
We love what's in the water,
Sure.
and we spend a lot of time figuring out what's in there. But it's around the bay that really matters. That's where we don't really have anybody living under there. We do have some dolphins that have names, but we have a lot more people on the shore here who have their livelihoods at risk.
Right.
And we don't need to take risks that we can fix.
Right.
We can't fix it 100%, but we can make it better.
Right.
So we need to have some more sea level rise instrumentation. We could have, in my view, I think there's 3 sites. One's at Selby Gardens South, because the water's deep there. One is near the bay, and one could be off the Ringling Museum, perfect locations, where we would have 3 sea level rise sensors in town. And that will help inform decisions. How fast is sea level rising right here? Well, we kind of know from the satellites, but we don't have any ground truth measurements, but now we will. So we can have those. I think one should be named the Greg Huffman Sea Level Rise.
I second that.
Right? I mean, you can see how this is going to go.
Yeah.
Once we get this going, everybody's going to want their name. Who wouldn't? I might even buy one.
So a follow-up question, if I may. So you talked about the cooling around, I think, Florida and the loop current last year. Was that caused by air temperatures? Like, did we have a cool season, and/or was it ocean upwellings?
Well, actually, the winter this
upwellings?
year was cooler, and the water was quite cold, but it warmed up really fast in a 2-week period.
Yeah.
And sometimes the currents are such that, we have a continental shelf that's very, very shallow here, goes out 150 miles, and it's 20 feet deep or 100 feet deep, and then it drops off and it's thousands, okay? But when you have upwelling up that coastal plain under the water rises up onto the continental shelf and it mixes. And just exactly the dynamics of that changes from year to year. It's not just weather systems, it's the dynamics of the currents in the Gulf. And we know the currents are not stable. They ebb and flow just like they do in the atmosphere. So it changes. It's the weather of the ocean, if you will, and the two of them interact. And this year, it just so happened we had a very nice, cool Gulf, and I was really excited about it until I looked at it a couple of weeks later, and I said, well, wait a minute, what happened? So,
One other follow-up, if you don't mind. Sorry for dominating, but they talk about the big
it's
ocean.
okay, you just spent $1,000.
Yeah, I know. Hey.
You can ask as much as you want.
And got a monitoring station named after me, right? Right? You heard
Yes.
him. So the last one is the larger ocean currents, like the Gulf Stream and such. I'm a scuba diver, right? So, and I know there's been scientists talking about there's a possibility because of climate change of those currents changing.
Well, so that's an excellent point, Greg, and it's part of the AMOC, which is the Atlantic Meridional Overturning Circulation, which is the big conveyor belt in the Atlantic where the water sinks and then it rises up in the Gulf Stream and then goes up toward Europe and keeps Europe warm. But it also pulls on the loop current in the Gulf. It goes right around the south tip of Florida into the Gulf Stream. Now, what's really interesting is that the speed of that current impacts sea level rise. Because when that current is strong, it pulls water away from the coastline. But when it is weak, the water slushes back to the coastline. And what we've noticed in the last couple of decades is the MOC has slowed down. And that's part of the reason we're seeing higher rates of sea level rise. If it stopped, we would get pretty fast sea level rise, so we hope that doesn't happen. And of course, Europe would, kind of get cold, like really cold. So, we're not forecasting that to happen immediately, but there is a possibility of that happening late this century, according to the different models. And I hope that we're smart enough to not let that continue. That's where Tom was talking about mitigation. Well, of course, mitigation has to happen. Adaptation gives us more time to mitigate, but it doesn't solve the big problem we have to mitigate at some point. Any other questions?
Bob, how many monitoring stations would you ultimately like to have? You mentioned 3.
How many what?
The monitoring stations?
Oh, well, so on sea level rise, 3 would be adequate. But on anemometers, temperatures, when you're going to test new products and services, let's say we're testing new wallboard. When a hurricane comes in and wets the drywall, what kind of products would be better to install, let's say, should storm surge come into Selby Gardens and something be ruined, what could they use that would be more resilient so they wouldn't have to keep redoing the way we used to do it? So we can test those kinds of things under actual conditions. And we can test surfaces for permeability, letting the water flow through. It still looks beautiful, but it's not concrete. We can test the heat impact of various what am I trying to say? Concrete versus grass versus pavers, so that the heat island effect that we create by our development is actually lower than it would have been. It keeps the city cooler. There's 1,000 little ways to innovate, but we don't have the specific data to show which one is best. We just guess. And we don't need to guess. We can test it, and that would be one of the outcomes of having living laboratories where redevelopment is going on. We can test different things to see which is best for which environment. I don't know if that helps you. Any other questions? Yes.
You just mentioned the living laboratory and testing building materials and how that's a gap you would love to fill. what are some other gaps you see? Whether, for example, and I could be wrong that this is a gap, but like, for example, more information on testing green infrastructure or nature-based solutions and filling that gap, or that kind of just speak to other
Right.
gaps you'd love to fill with the
I
living
mean,
laboratory.
think about this, right? Shelby Gardens is putting in a living shoreline. I can't wait, because I want it to be instrumented to the hilt, so we can measure every little thing we want to know, like how many more fish do we have, and how fast can we grow mangroves, and how fast does the biosystem recover after a storm event. The same thing at the bay. We're going to do that at the same time. Think about that. We're going to have 2 major institutions doing soft shorelines. We don't know exactly what the best thing is going to be, but as we go through this, we'll innovate. It's a dynamic system, and so is the climate dynamic. So this gives us a way to innovate in a hurry, and also then to direct our investments in such a way that they have impact, not just to guess what the answer is. You know, it's not multiple choice, you know. Yes?
What's the cost of one of those, you know,
A sea level rise gauge, you know, I'm not saying permitting because it depends on that, but let's just say the instrument thing is around 50,000. It's, I mean, yeah, it's only 4 zeros, or is it? Karen?
Bob, you highlighted the 6 sites that you'd like to have involved in the living laboratory. I'm curious why Moat wasn't included as one, Moat on City Island.
Well, part of it is because it's facing the Gulf of Mexico.
Well,
Well,
it's on the
City
bay.
Island, you mean the old research center?
The old research lab
Okay.
on City Island, yeah.
Well, it actually could be.
Seems like it would be valuable, particularly from the
It
expertise
really
that's
could
available.
be. What we decided to focus on first is the bay on the mainland, because I think the risk here is probably the most solvable right now. I think the barrier islands are, and close to the barrier islands are tougher, and they're getting tougher every year. And so, but here is kind of like, that's where we have to draw the line. We have to draw it somewhere. And I want there to be results that are quick, and then I want there to be an extension of the living laboratory to more risky areas than what we have, and to larger areas. But if we start with this, I feel like we can manage this. I don't want to get ahead too much, because that increases the probability of failure, and we cannot fail. We have to win on this. And so I think this is a great plan as a starting place, but I want to say it's a start, it's not a finish. So, but Karen, I agree with you. And maybe we could talk to Dr. Crosby about that. And I think he'd probably be pretty interested. Anyone else? Well, I don't know what time it is, but we're half an hour late. Oh, thank you. And that's really good for me. So I thank you so much. And I do want to say, I believe it's on November 12th is the next Florida Climate Conference right here at USF. And there'll be details about it, but I can guarantee you AI dashboards and modeling is going to be part of it this year. So thank you so much, and thank you all. I appreciate it.